Thank you very much. With this presentation, I plan to attract attention of those interested among you to the opportunities which are given by the interrupted time series analysis and share some precautions as well. What I plan to do is to show or remind you of some of the examples, of beautiful examples in tobacco control, which were based on the interrupted time series analysis, to remind of the experimental designs which we use to evaluate the effects of interventions, to remind of the conceptual approaches which are used in the interrupted time series analysis, to share the example of analysis of routine tobacco surveillance data from Ukraine, and to express some ideas regarding main challenges which we can encounter in the interrupted time series analysis use. So, first of all, most beautiful examples of interrupted time series analysis in tobacco control. Probably most of you are familiar with these cornerstone works from California, when it was shown that the trends of sales of tobacco can be changed when certain tobacco control policies are implemented. This work was dated 1995, and a later one shows already that even more policies show the decline in tobacco sales. And this is definitely the evidence which allowed us implementing these effective tobacco control policies in many countries. Another study from Australia regarding the implementation of plain packaging. You see that routine data measuring attitudes of smokers to packaging, to tobacco packs over many years. Four indicators are shown here. Some of them were introduced early, others were introduced later. And after the plain packaging was introduced, we see how these trends have changed. Again, they're interesting, but when we look at it as just random numbers which change over time, it is not clear what to do, but interrupted time series analysis helps us with this. Another study, again regarding the introduction of plain packaging, and here we can see that interrupted time series analysis can not only use the measurements of the indicator, which is our outcome, but also can consider as potential predictors certain tobacco control policies, cigarette price in this case, but also can account for certain potential confounders. Another example shows that in using interrupted time series analysis, the researchers can not only adjust for confounders as in the previous work, but also take into account effect modifications, stratify the study group by certain characteristics. Just to remind to those of you who may be less informed about that, how we measure effectiveness of certain interventions. The gold standard is the randomized controlled trial, where we have some of observations of participants which can then potentially be divided into groups. Then we randomize them. One of the groups is exposed to what is our intervention, and we observe what happened with them later. In better studies, we expect that we have longer follow-up, and this adds power to our studies. But sometimes, and actually in many cases in public health, in tobacco control, randomization is impossible. And sometimes it is even impossible to have a control group. And actually, this happens in most cases when tobacco control measures are implemented over the whole country, and usually we don't know when it happens because we try to lobby implementation of certain policies, but we are never sure when it happens. So it is quite difficult to plan something in advance and to conduct some rigorous studies. But sometimes before and after the implementation of a certain policy, we already have some measurements, especially of some routine data, and we have these same measurements after the implementation of the policy. And if these measurements are done at equal intervals, then it becomes an interrupted time series design. If another territory has similar measurements but has not undergone similar policies, it can serve as a control, and then we have an interrupted time series design with a control group. So, what are the conceptual elements in interrupted time series analysis? First of all, we need to remember that something may change in the indicator, which is our outcome, according to different scenarios. First of all, our change can be permanent, it can be permanent, or it can be temporary. It's something increased and then decreased again, increased and decreased. And the change can be gradual, like here, or it can be abrupt. Something changes just after the policy is implemented. And if we have certain trends, we take into account that both the level of the indicator and the slope can be changed, and if we have two groups, one experimental and the other the control group, in both groups we can see changes in levels and changes in slopes, and all this needs to be taken into account and analyzed. For example, this can happen something like this. The core element for the interrupted time series analysis is the so-called ARIMA, which is autoregressive integrated moving average model suggested by Box and Jenkins. This model takes into account autoregressive terms. What it means is that our current measurements are not independent, but they are somehow predetermined by what was happening earlier. And measurements at certain intervals can be correlated, and this would be autoregressive component. Then we also take into account difference between the measurements, and another element is the so-called moving average. So, first, what is done in this analysis is the analysis of how our measurement changes by itself. And the other thing is expressed as dynamic variables, which actually represent our potential predictors or our potential confounders. And just an example of routine data produced by the National Statistics Service of Ukraine since the year 2000. They measured once a year in certain groups the prevalence of smoking. And what happens if we analyze this data using interrupted time series analysis? So here we have years. From year 2006, we have comparable data. Here we have the prevalence for the whole population for some groups. And here we have those dummy variables, just to explain a bit how they can be expressed. They can be binary, like here, for tobacco affordability index. Has it changed in a particular year? If it hasn't changed, if it didn't change, then it is 0. If it changed, the tobacco became less affordable in that year, then it is 1. Same for smoke-free events. This is another dummy variable. If something changed in smoke-free policies in Ukraine, then it is 1 for that year. But sometimes we can use these dummy variables also as ordinal variables. And I use them to distinguish those changes which I attracted your attention to. For example, if we want to see whether something is happening abruptly or gradual, we use for this our ordinals or binary variables. And if we want to see whether the change in the level of certain policy leads to constant change, in this case, in prevalence, in sales, whatever, then we can use this ordinal variables. So this is just a calendar to take into account in which years what happened. Price increases happened in these years, and something changed with health warnings in this period, and something changed with smoke-free policies. So first we analyze what happened with ARIMA of this measurement, prevalence. First of all, prevalence of smoking among the Ukrainian population. And as potential predictors, I added, first of all, in the model, those dummy variables which were related to taxation, because we expect that it should be important. And here we have two variables, and see that with both of them, change of these variables by 1 would result in the decrease of the prevalence also by about 1%. Further on, another policy which was changed in this period was related to smoke-free policies. Here again we have the average estimate around 25%, which is close to reality, but we see that the best explanation and the most significant model is achieved with a delay of 3 years. It means that the prevalence of smoking is expected to go down after 3 years of smoke-free policy change. Another policy change which happened in this period was related to introduction of new tobacco health warnings. And again, we see that some decline in the prevalence we see 2 years after the introduction of the new warnings. And when all these policies, the dummy variables for all these policies are added to the same model, we see that the associations with the taxation became less significant, and again, smoke-free policies have the delay of 3 years, and same when the other variable for taxation is deleted. But you see, what happens? the model shows that the prevalence of smoking goes down 3 years, 1, 2, 3 years after the smoke-free policy was introduced. But in this year, we see that taxation was changed. Again, in 2012, smoke-free policies, stronger smoke-free policies were introduced. But again, 3 years later, again, we see quite strong changes in taxation. Further, you see similar models for men, again with these three years, strange 3 years, which is not very feasible, that the prevalence will go down 3 years after the policy is introduced. And less significant impact of taxation in this case, and same for women, again. So it is quite likely that some variables which characterize certain policies would mask something else. And after these considerations, I return to those original estimates that taxation, this was the ordinal variable, and this shows that every increase in taxes was related to about 1% decrease in overall prevalence of smoking in Ukraine on average. And in those years when the price of cigarettes was abruptly changed, also about 1% of prevalence went down. And same was for, yes, I'm finishing, thank you. Same we see for men. In Ukraine, we have a much higher prevalence of smoking among men, and the decline is by, on average, 2%. And men also would react to the introduction of new health warnings, and this also is related to the decline in the prevalence of smoking by about 2%. So I would like to summarize that we see here certain challenges. Interrupted time series analysis gives great opportunities, and especially when you need to analyze routine data which were collected in your country for many years. It is a great instrument. Still, we need to take into account certain limitations and challenges. First of all, there is a risk of multiple testing with this analysis. Statistical power can be an issue, especially when you have a relatively short time series. It is possible to get overfitting if you use the suggested expert model, which I do not recommend. All the changes in the indicator can be explained by itself, and we see that policies introduced simultaneously can mask one another. Thank you for your attention here on my.
Keep the microphone. Okay. Yeah, I'm sure there is some question about this interesting presentation about methodology and example for Ukraine. I've got some, but the floor is yours for the room. Madam?
Thank you for your presentation. My name is Tatiana from Turkey. I wondered if there are other examples from the law about the duration. You gave 3 years for expect the decline, right? 3 years after the smoke-free legislation, the prevalence is expected to decline. If I'm not wrong, you have mentioned that.
I show this as an example of policies masking each other. In fact, it is more likely that the prevalence declined as a result of tobacco taxation. But because the smoke-free policies were also introduced in this period, and when we add in the model only smoke-free policies, we see that as if the prevalence declined 3 years after the smoke-free policies were introduced, but most likely it was not the result of smoke-free policies, but the result of tobacco taxation.
Yeah, I understand. I understood correctly. So my question is the other inputs to the process. For example, we have violations in Turkey. We have smoke-free legislation. Unfortunately, we have violations. So, do you have any recommendation for such cases using those kinds of models? Thank you.
Thank you. Yeah, it's a very interesting question. Actually, we can play quite effectively with these dummy variables. You can use something like expert estimates. To which extent certain interventions change the situation in a particular year. For example, if 100% smoke-free policies were introduced, this would be 1. But if it is to only some percent, maybe it would be 0.3, yeah, or something like that.
Thank you.
Other question? Yes, here.
Thank you very much. Very interesting presentation. Considering everything what you said, and also that the tobacco control policies more or less are always implemented comprehensively, is it any chance to separate the impact of separate measures with this methodology or not?
In general, it is possible, and this is what I call the audience to. If you use this method, the idea is to try to tease out the effects of different policies. In some cases, in some countries, it is easier than in others.
So, do you have also you have to have data of implementation of these policies or not?
Yes, we know in which years what changed, and we take this into account. Because we live in this country, we can observe, and we have data from the surveys, how people perceive these changes.
Okay. If there is no other question, we can carry on in the session if you have time.
Thank you.
Yeah, you're welcome to exchange a bit later with